I represent German precision and American craziness. Okay. I welcome my friends from Serbia and from the land my parents come from. So I'm very proud that they could come and visit me, and I'm going to return the visit. In the meantime, they're in the music business, and these are the people that I've got to lay out the facts so they understand it from the point of view that I did. It's a strange business. There's no other business like the music business, because it's ruled by tradition. And it's sad to say, but some of the tradition, when it began, was wrong at the start, and people still live by it, which is that if you want to play with traditional methods, you have the traditional problems. It's as simple as that. So my friends here, I'm just going to lay out what I found that's definitely wrong with the business, and what I did to correct it and make sure that the instrument would get its ultimate ability, which nobody can do right now, because you've got all these collector vintage guitars and nobody can play them. So no matter how good the guitar is, they still can't play them. They're in the shelf and they're just for conversation. So the experience I got by making tuning keys for one of the big companies that used to be in Cleveland is how I got my insight on what is wrong with all the complaints that I heard from all guitar players. And I myself don't play a guitar, but my background has been engineering and always improving products. That's the way I made my living in the past. And I was a consultant for people like Eaton. We did work for Boeing and the biggest companies in the country, so everything had to be right. And when I got an insight in tuning machines, I couldn't believe that companies that had big names in this industry didn't make a better product. So in the business I was in before, the tool makers that worked for me, they all retired, and you couldn't. And this kind of work we'd done was like a lost art. So I've got it, and so I thought there's a opportunity here in this business to correct it, and because there were so many faults. Okay, so now we'll start on the tuning head. In other words, there is so much tradition and stories going on that everybody's been brainwashed. And one of the big stories is that that you see in all the magazines is these guitars have die-cast, chrome-plated machine heads. That in itself is pinpoints the problems with tuning heads, as I'll show you in a little while. The other thing I did when I went in this business, I examined all the heads there are, and I noticed that in these heads there were 10 flaws. And the problem is that nobody has ever taken a machine head apart and took a look of what really makes it work, the kind of tolerances. So anybody that's had a machining or engineering background would take some of these keys apart. They would be in the same position that I was. I couldn't believe that people expected guitars to stay in tune with this kind of workmanship. And so there were actually, I recognized 10 flaws in every key that's made. And my idea was to correct every one of them, which I did. And the thing that you got to remember is that when these original keys were designed, the Grover key was originally designed in 1923. And it was by a sort of like a backyard machinist. And at that time, the guitar industry was starting to grow, so everybody needed tuning keys. Then an outfit in Chicago by the name of Kluson, which were two very good tool and die makers, they come up with the Kluson key. And this was to fill the gap. But these keys at the beginning, there was competition to get all this growing business, to get the business, that price was a big thing. So everybody that made a tuning key, price was the big feature to go for. And that's evident in all the keys that have been made. And at that time, everybody was anxious to get them on. So the first keys that got on the guitars got the traditional names, that are well-known names of today. But they also have, like a Grover has 80 years of experience in the business, and without one improvement in 80 years, it's still the same thing. And how many times have guitar players replaced keys? And that alone tells you where some of the flaws are. So when you take a key apart, you find out where the whole story is. And in the first place, I wanted to point out that guitar players are the kind of people that they buy a product, and if it doesn't work, they're so interested in playing it and doing good with it. They do the best they can and they accept it. You buy any product in the market today, if it doesn't work right, you take it back and you complain. Guitar players never did that, and that's why these problems kept going on without improvement. And which was a great factor for the OEM, the producers of guitars. They didn't have to improve anything, and they didn't want to make more improvement because the price would go up. And part of the price problem is the big markup that music stores make on a product. So that's where we're at. So we get back to the diecast key, and what I did here is I've taken a Grover key apart. And what you got to remember is when Grover came out, they were the first enclosed key. And they made such an impact on the industry that Schaller and everybody that got into the business, they took the Grover key and thinking that was the perfect key, that they copied it. And the mistake they made is they copied all 10 bad features that were in the key. They never corrected it because they thought this is the element. So, and what it actually comes down to, and one of the most significant parts of how guitar players have actually been fooled all these years, and they're actually fooling you guys through what they do with this key. The first thing that I noticed, and anybody that wants to talk about keeping a guitar in tune, is when you look under the button, you see a washer and a bowed spring washer. This itself is a bad feature, because what you have here in a very sensitive position is a flexible member. And that flexible member, anything that can move the string post is a problem. And that is one of the problems. When I used to go to the Ovation guitar booth and try to sell them my key, I would go up to them and say, "Beautiful guitar, but you got terrible keys." And they'd say, "Why is it?" And all I did was go put my hand on a guitar, put my heel here, and pluck the string and push on the button. The spring gives and you can hear it. So what is it doing there in the first place? And that's why the story of the diecast comes in. What is it doing there in the first place? It's to fool you of a feel. That's what it's there for. Because if you look at the end of the button here, when they mold this, the mold comes together and there's a parting line. And the parting line happens to be up on this front edge. Okay? And that also happens with the parting line that's on the housing. You can see this right here, that there's a bump there. That's the purpose of the spring. It's to fool you. Because when these high points come around, the spring gives. If you put this on without that bold washer, you got the feel is gone. So everybody thinks that if it feels good, it's a good key. But that's what happens with a die-cast key. You take my keys. We have a separate. It's separate here. It's not die-cast. This every piece is machined. Every surface is square with the hole, from the housing to this the way it fits. That's why we don't have to have a washer there. And that's the problem with die-cast. The other reason with die-cast is that you can never control dimensions, because nobody can control the thickness of the plating on a part. So when you go into mass production the way this is produced for price, that when they make these parts, that the mating part, the worm that goes in here, they have to consider what is the worst condition when they plate it. Okay? So what happens is they say if the hole closes up 3 thousandths, this has to be made smaller so that in assembly it's going to go in. Okay? So what happens if at this time they plate it and they get a housing that doesn't have the 3 thousandths plating, the hole closing up 3 thousandths, and it's a minimum plating? That makes the fit. Now this here, whatever the hole is larger, it adds more slop. So in other words, there is no definite support for the end of this worm. And if you take this and measure it like I did, and you can take this and check it, this is 5 thousandths smaller in diameter than the hole. That means that when you put this in here, you can take it, feel that. That's the slop. So we went to aluminum because we didn't want to plate. The process of anodizing turns the aluminum surface to a hard aluminum oxide. And if you get a black anodized, as a matter of fact, some brake pads are made out of hard black anodized. And so that's what was our initial plan, is to take this and have everything machined square, and that when we determined diameters, we could make them so that there was a fit. And the tolerances that we have out in the shop right now are plus or minus 1,000. Okay, so now we go back to the plating again. So if you've got this here, and I'm sure everybody is familiar. Oh, I got to take this apart. But I'm sure everybody's familiar with the wobble in here. Okay. So how do you eliminate that wobble? The wobble is because if you're going to have a part plated, if you're going to have a thread plated, and you want it to mate with something else, because you never know what the plating's going to be, you have to have the tap cut at least 7 thousandths bigger so that it'll go together. So now when you take this housing, and you got a double problem here. You got two parts. You got this part that you don't know what it's going to be because you plated, and you got this part that's you don't know. Now how are you going to match these two parts? And that's why you have this, because they can't come up with a good fit. And what was our simple answer to this, which nobody recognizes, is that we put the thread on the outside. That means that if we take a post and put it in there, you got support all the way up to the end there. And that was a very simple, and all these features that are some of the 10 problems that are in there. It was very simple to put the thread on the outside. That means that you have a full diameter of support from here right down to the bottom of the post. And what do you get on the other post? This is a 2-piece post. And the reason that they have it like this is that they put it in from this end here from here, and then they slip this on and put a screw in to keep the play. But they can never again get a definite, accurate fit because they never know what the tolerances are going to be on the die casting and the plate. And why did they do this? It's for the simple reason that it's cheaper to run the bar in like this, and there's no material waste. What we do is we are the only ones that make a post that's 1 piece. And the reason for that is you get perfect concentricity. You don't get perfect concentricity with this because they got to make this separate and then they got to put it on here. And it's almost impossible to get this to be perfect. Which ours is, everything is concentric with the main diameter. And what did we do about the 2-piece thing? To show you how accurate we are, is that when we machine this, there's a groove here that is within 1/1000th of the bottom of the post. What happens here, when we machine this, the back of this surface here is where this surface goes in, is that where that groove is. That's matched on the inside, and the way we put it in, no screws, nothing, is we come in here and we cut metal and push it into that slot. That's why we are the only key that has 0 end play. These people, because of production tolerances, will never get 0 end play. And that's the reason why, like I explained the other day, is why the treble side goes out of tune more than the bass side. Is that this movement of up and down. Because all of a sudden when you tune on the treble side, you're turning down. The worm turning down puts torque on the gear and pulls the post down, creating the greatest amount of movement for up and down. When you turn on the bass side, you push it out. And isn't that funny that on mandolins they turn right hand instead of left hand? So that may be the reason why Leo Fender put all 6 on one side. But we even improved on Leo Fender, because what was the problem with Fender's idea? Instead of all guitars like a 3 and 3, everybody wants more downpull on the high E. When you do it with the Fender system, okay, the high E is way down the end, so they had to put string trees on. So what was a simple thing there as far as you're talking about cost, is we are the first ones we invented graduated post heights. Eliminates the string trees. Now, as long as a Fender guitar has been made and all these people tell them, where the hell was everybody at for 50 years? That couldn't even realize that this was something, because everybody playing didn't like the string tree, especially even the guy starting to play with the tremolo, because the string tree interfered. So that's some of the things where Sperzel comes from, is we recognize all the things that were never corrected. And that again is because Fender made it that way. That's the law. See, but if you look at when we made the Strat Plus, and they tried our keys, and was the fact that they made the statement that this was the first significant change in tuning capabilities. See, but then again, we made a mistake at that time. We weren't really ready to fulfill the orders that we got, because the guitar took off. So what did they do? They turned around and went to the big producer, Schaller, to do it. So anyway, but then when we get in, then we get into this thing as far as what they talk about. Another thing that you guys are absorbed with is the gear ratio, 14 to 1. Everybody is brainwashed that 14 to 1 is better. Now they're going to 18 to 1 and whatever it is. But let me show you the difference here. That the gear on here, how long do you think that gear tooth lasts? 18 to 1. Look how thin it is. Take a look at the gear. And the way this, and with all the slop that's in the housing here, the principle of making this key was, and that's why, again, tradition, is that the post is in front of the worm. And what is the theory from there? Is that they know this is going to tip, right? So, and because the only bearing that you have on this post inside the housing is right there. It's less than 1/8 of an inch. Because you got the bushings going in from here, which with our key, you have the bearing all the way down to the inside. So that's part of the problem. What they had, what happens is that when you put the gear and the post together, you never get perfect concentricity. So what they did, and that's the design of the guitar again, is that the post had to be in front so that they counted on the string tension pulling, and they knew this was going to tip. And what did they want? They wanted it to tip into the worm. That's it. But if you've got a worm that has no support, that has 5/1000 to 7/1000 play, like I showed you in on the end, and then you've got a string post that wobbles, you know, what do you expect from a mechanism like this? And that's why everybody's been screaming for 50 years. So what we did is we went and we said, fine, we're going to make this thing out of aluminum because we can anodize it and we can have precision. And we put the tread on the outside so that you have full support, which nobody else had, right? And the other thing was that the other drawback on that was the fact that everybody, again, tradition, is used to a plated key. And so that was the drawback on. So what we did is we say that the body should be anodized and everything else can be chrome, because the body houses the main components. And if you look at our system, it's every component is supported, and so it mates perfectly. And one of the big features that nobody recognized, that I'll make a little sketch of, is one of the main features of the whole system, to show you how deep we went into this, to make sure that you have concentricity and that you have everything mating and all components are supported, is that when you take a look at our key and you take a look at our worm, you'll notice that our worm has a big diameter on the end, where the competition has that small diameter that has wobble and gives you waggle. Okay, so what did we do? So we said, we want that every center line, between the center line of this and the center line of the mating gear, is going to be kept as uniform as possible, because you got factors to maintain the diameter of the tread, the same thing, the diameter. So that puts a pretty good pressure on you to maintain center line distances. Because if you add a center line variation to those other measurements, you got a real problem. So what was the answer to that? That again, nobody recognized, because nobody takes the gear apart, and this opportunity you've given me to demonstrate this thing explains it. So what you have, if you've got a hole and you can't control the thickness of that hole, and you want to make.
So you can see it.
Okay, and you want to have the mating part like I explained before, and you got to play the thickness of plating. Then even the thickness of or the diameter of a tool wearing in the machine, because there'll be some variation. What we did is we brought the housing up. This is the housing, and that's the hole. What we did is we put an angle here. And on the head of our worm, we have a special developed radius. And you know what happens? No matter what size hole you have here, these contact points right here are right in there. We have the same thing on the other end of the housing. And our spacer fits in there with the same curve, with the same principle of the curve. So no matter what size hole this is, when this stuff comes in, and because the ends of our parts are all square, that when you tighten down the screw on the end of the button, everything lines up. And that means that you get contact here, and because you've got this radius, it's a ball joint type of fit. So what happens when you tighten that down, everything comes down and lines up to a common center line. And it doesn't matter how big holes you make. And that's the main principle of our key. And nobody else is recognized. And this acts like the valve seat in your car. And that's the same principle you have on both ends. And what's happened now, if you get a customer and he wants a reverse set of keys, you know how accurate that this is machined? That you take the worm out, take the button off, take the worm out, put it in reverse, put the button on the other side, and it's perfect. You can't do that with any other machine there is. And so that's more or less the game they're playing with you guys. It's from that, and the initial one is when you come to that spring under the button to hide the high points of the diecast housing and the diecast button. And ours are machined square. And those are the things that nobody recognized, because no manufacturer has ever taken a key apart to see actually what they're buying. Yeah. So I guess that's about it. But what you got to do is you got to remember this: traditional methods didn't get us to the moon, and traditional methods won't keep your guitar in tune. Okay. And the proof of how good our key is this thing that we developed with the D thing, where you can go back and forth to drop tune. Shows you how accurate this key is, and the accuracy in all the moving components, that you can do this and it repeats. Because all components are controlled, bearings are there, and you can't get that in any other key. So I think that's about the end of the story.